Python. Firstly, let's take a look at what is linear regression. Introduction to linear regression. Linear regression is a predictive modeling technique. It belongs to supervised learning. It is to find a mathematical equation for continuous response variable y as a function of one or more x variables. Y is what we call as dependent variable because the value of y is dependent on the x variables, and x is what we call as independent variable. So that you can use this regression model to predict y when you know the x. Expressions. Y equals to beta 1 plus beta 2 times x plus x ln. Beta 1 is the intercept and beta 2 is the slope. They are called regression coefficients, and epsilon is the error term. The part of y that the regression model is unable to explain. Example problem. For example, we have a data set. It consists of 50 observations, while that is 50 rows, and 2 variables, that means 2 columns, distance and speed. Currently, we want to use the speed value to estimate the distance value. So the distance is our dependent variable and speed is our independent variable. No matter in your assignment or in other projects, figure out which column is your independent variable and which columns are your dependent variables are very important. The goal here is to establish a mathematical equation for this as a function of speed, and then we can use it to predict this when only the speed of the car is known. Graphical analysis. Graphical analysis will help us understand these variables graphically. First one is the scatter plot. It helps us to visualize the linear regression relationship between the predictor and response. So this is a very quick example of scatter plot. We predict the speed as the x coordinator and this is the y coordinator. Then we can see the relationship between them. From this scatter plot, it suggests a linear and positive relationship between the distance and speed. So the good of the underlying assumption of the linear regression is that the relationship between the response and predictor variable is linear and additive. So let's take a look at the assumptions of the linear regression. Before we do the linear regression, we have to check whether the data match 4 of those assumptions. First one is the independence of observations. In our class, all the data we got are assumed as independent, so we don't need to worry too much about the first one. Second is normality. We can use the histogram to check the normality. The normality means whether the data set is normally distributed. Linearity is that we have to use some graphic to help us to determine whether the data are linear correlated. For example, the scatter plot is a very good function. And then homoscedasticity. That means the variance of residual is the same for any value of x. That is the part of epsilon, the part of y that the regression model is unable to explain. We want to make sure that all the epsilon for all the x's are the same. Why do we need those images? Those images gonna help us to understand the data at first, and it will help us to check for the 4 assumptions of linear regression. After we build up the first images, we can build up the linear regression model. So for example, you have seen the linear regression in the scatter plot, and there are several functions used in building linear regression models in Python. In our example, the function we use are here. We have to import NumPy and import the linear regression from the linear model. After that, we can build the linear regression model. So you have to build up your x and y, the dependent variable, independent variable at first, and then create the model call the linear regression function and then use the model to fit the speed and the dist. Again, the speed is the independent variable and the dist is the dependent variable. After build the linear regression model, we can find out the most important values. For example, the intercept and the slope are very important because the formula could be determined by the intercept and the coefficient and the slope, And after we got those two values, we can see that the formula should look like this, equals to model dot intercept plus model dot coefficient times speed. And we can also use this model to do the prediction. We put the value of speed into the function of speed as a parameter, then it could help us to do the prediction. Also, we can define our own function. In our own function, the speed is a parameter, and it's gonna help us to return the value from this formula. And then we can build up the model of the list of value that contain the my function and the speed. Then we can plot the scatter plot, while the speed is the real independent variable and the dist is the real dependent variable. And the speed again is the real independent variable, and my model is the estimate variable. Then we come up with this image. The data point, the data dots are the real value, and the line is the predicted regression model. Linear regression diagnostics. We have to make sure that it is statistically significant. So firstly, R-squared. R-squared tells us is the proportion of variable in the dependent variable variation that has been explained by the model. So we check the R-squared function, the R-squared value over here, and there's more diagnostics function. Can apply the code like that, and the p-value will consider the linear model to be statistically significant only when both these p-values are less than the predetermined statistical significant level of 0.05. By using this part of function of Python code, we can come up with the regression results. In here, you can find the R-squared value as well as the p-value. P-value is here, so both of them looks good. Then we can make a conclusion that making a conclusion is super important. The conclusion should include the inside the conclusion. You should have firstly, one, do you believe you can use the linear regression? So I have to check the 4 assumptions. Second, what is your model and linear regression you found, linear relationship you found, that is the formula you found here. You have to put your real value of your model intercept and the model coefficient put in. And thirdly, how does this model behave? The p-value, the R-squared, and the performance. Fourthly, how do you want to use your final model to do predictions? Like if there's a new value, new upcoming x value, how you want to use the predict function to do the prediction. Yeah, that's it.